Welcome to the virtual lab of engineering chemistry prepared by the Department of Chemistry of KPR Institute of Engineering and Technology, Coimbatore, Tamil Nadu. The first experiment of the course is the determination of total hardness, permanent hardness, and temporary hardness of water by EDTA method. The aim of the experiment is to determine the total, permanent, and temporary hardness in the given sample of hard water by EDTA method. You will be provided with standard hard water of known strength and EDTA solution. Water is of two types: soft water, which lathers with soap and has all the salts except calcium and magnesium, and number two, hard water, which forms a scum with soap. It contains calcium and magnesium salts. Hard water is of two types: temporary hardness and permanent hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium and can be removed by boiling and addition of lime, while permanent hardness is due to the presence of chlorides and sulfides of calcium and magnesium and can be removed by the addition of soda lime and zeolites. To perform the experiment of hardness, we require number 1, EDTA. EDTA is ethylene diamine tetraacetic acid. The structure has one ethylene, two amine groups connected to the ethylene on both the sides, and 4 acetic acid connected to the amine groups. EDTA cannot be used as such as it is insoluble in water. So, 2 sodium is added and it forms disodium EDTA, which is soluble in water and easy to perform the experiment. EDTA is filled in the burette and it is a complexing agent. The complex is formed between EDTA and the hardness producing salts. EBT is used as the indicator. EBT stands for Eriochrome black tea, which is steel blue in color. When it is added with hard water, it forms a wine red color. An additional solution of ammonia buffer is also added in this experiment. Ammonia buffer is a mixture of ammonium hydroxide and ammonium chloride. Ammonia buffer is added to maintain the pH between 8 to 10. This is because only at pH between 8 to 10, EDTA forms a complex with hardness producing salts. The principle behind this experiment is simple. Calcium and magnesium salts are the hardness producing salts. On adding 5 ml of ammonia buffer solution and 3 drops of EBT, a weak complex is formed between EBT and the hardness producing salt, giving it a wine red color. Since ammonia buffer is added, the pH is maintained between 8 to 10, and on titrating with EDTA, a strong complex is formed between EDTA and the hardness producing salt. This eliminates EBT, replicating a steel blue color, since EBT is steel blue in color. So, the end point is marked when the color change is from wine red to steel blue. 3 types of water sample are taken as pipette solutions. For titration 1, standard hard water sample is taken. For titration 2, sample hard water is taken, which estimates the total hardness present in the water sample. For titration 3, the sample hard water is heated, cooled and filtered to remove the temporary hardness. This is taken and titrated to estimate the permanent hardness present in the water sample. On subtracting the permanent hardness from total hardness, we can estimate the amount of temporary hardness present in the water sample. It has to be filled in the burette. 20 ml of standard hard water has to be taken in the pipette and transferred into the conical flask. 5 ml of ammonia buffer has to be added to maintain the pH between 8 to 10. And 2 drops of Eriochrome black tea indicator has to be added. The color of the hard water changes to wine red color. Sample hard water and boiled water are also kept for the experiment to be continued. To pipette out 20 ml of standard hard water, a bulb is used to suck out the hard water from the bottle. The bulb is pressed to release all the air present, and the mouth of the bulb is fitted gently onto the mouth of the pipette, which sucks the standard hard water till the brim of the pipette. On releasing air at the mouth of the pipette, the solution level lowers. The sample is set when the lower meniscus touches the mark in the pipette. Water is then transferred into the conical flask. Blowing of pipette is not encouraged. The solution gets completely transferred, followed by a gentle touch at the bottom of the conical flask, which releases the maximum content of pipette solution into the conical flask. To fill the burette, EDTA solution is used. A funnel is fitted to the mouth of the burette, which is rinsed with EDTA solution. The clean burette is then filled with EDTA solution. Then the funnel is removed and the level is set to 50 ml when the lower meniscus of EDTA touches the zero mark of the burette. It is then fitted into the stand. To the 20 ml of standard hard water which was pipetted into the conical flask, 5 ml of ammonia buffer is added. This is to maintain the pH between 8 to 10. And 3 drops of Eriochrome black tea indicator is also added. A wine red color is then seen. This is due to the weak complex formation between EBT and the hardness producing salts. The solution is then titrated against EDTA. As EDTA is dropped into the conical flask drop by drop, the conical flask is rotated in the clockwise direction until there is a change in color from wine red to steel blue. A clear change in color is seen. The change from wine red to steel blue can be clearly noted. The experiment is repeated twice to get concordant values. The same procedure is followed for titration 2 and 3. The short procedure for the determination of hardness is as follows. For titration 1, which is standardization of EDTA. EDTA is taken as the burette solution, standard hard water as the pipette solution, ammonia buffer as the additional solution, and EBT as the indicator. The end point is from wine red to steel blue. The same procedure is followed for titration 2, which is the estimation of total hardness, and titration 3, which is the estimation of permanent hardness, where the pipette solution is changed. Sample hard water for titration 2 and boiled, cooled and filtered hard water for titration 3. Looking into the calculation. For titration 1, the experiment has to be repeated thrice and the concordant value should be entered. Concordant value is the identical value received during the titrations. This is the volume of EDTA consumed. Using this, the strength of EDTA is calculated using the formula V1N1 is equal to V2N2, which is substituted in the calculation of titration 2 and 3. For calculation of titration 2, which is the estimation of total hardness, the titration is repeated thrice for concordant values and the volume of EDTA consumed is absorbed using V1N1 is equal to V2N2 formula. The strength of total hardness is calculated. The total hardness present is calculated using the formula strength of total hard water into 100, which is the molecular weight of calcium carbonate, into 1000, which is the amount of solution prepared. For titration 3, which is estimation of permanent hardness, the titration is repeated thrice for concordant values. The volume of EDTA consumed is calculated using V1N1 is equal to V2N2 formula. The strength of permanent hard water is calculated. The permanent hardness present is calculated using the formula strength of permanent hard water into 100, which is the molecular weight of calcium carbonate, and into 1000 prepared for 1 liter. The result is given in ppm or milligram per liter of permanent hardness. Finally, temporary hardness is calculated using the formula the amount of total hardness present minus the amount of permanent hardness present. The result is given as dash ppm of temporary hardness. The result obtained from titration 2 and 3 is summarized as the amount of total hardness of the given water sample in ppm, the amount of permanent hardness of the given water sample in ppm, and amount of temporary hardness of the given water sample in ppm. Thank you.